Awesome. So a lot of people are excited to be here and learn about schema-based instruction for problem solving. I'll give it about one more minute and then I'm going to go ahead and get started. The attendee list is gradually increasing. We should have a full house today. All right, I'm going to go ahead and get started. It's 4:01. So welcome to today's webinar. It is titled Schema-Based Instruction for Problem Solving. And I'm Kristen Williams. I'm the Mathematics and Special Education Specialist here at the Virginia Department of Education. And my wonderful colleague, Dr. Teresa Lee, is joining me today. She'll let you see her face for probably just this minute or so. But she's going to help me manage the Q&A and the chat. Because like I said, there are quite a few attendees today participating in this webinar. So in the chat box, I'm going to go ahead and put a link to our learning disabilities page on the VDOE website. And if you go to this link, this will take you to our designated page for learning disabilities and mathematics. And it also includes the 2 links to our new resources that we have that I'm going to be talking about today. I will go ahead and put it in the chat again, just for those of you who are just joining. All right, so welcome to today's webinar. As far as engaging in today's session, originally I wanted to do it as a Zoom meeting because I really wanted to have some engaging interaction and work in some groups and so forth. But there was an extreme interest in learning about schema-based instruction. So I really wanted to open it up to as many people as possible, meaning that I had to turn it into a webinar format. So as far as how you're engaging in today's presentation, if you could kind of keep the chat feature in terms of responding to any questions or prompts that I ask the audience, that would be great. If you have any particular questions, if you could put those in the Q&A, both of those should be at the bottom of your screen. And Teresa's going to help me manage the Q&A, and we'll probably stop periodically through the presentation. She'll probably answer some of them in the Q&A, and then any she wants me to address to the whole group, we'll stop and talk periodically. So I did put that link in the chat. I'll do it one more time for those of you just joining. But that link takes you to our Learning Disabilities and Mathematics page. And we were super excited towards the end of the summer. We were able to add these 2 wonderful documents to our website. And they've been very, very helpful, I think, to all of the educators in Virginia. One of them is a frequently asked questions document that kind of highlights the characteristics of disabilities in mathematics, as well as what kind of accommodations and assistive technology and different supports that can help them be successful. And then the companion guide is a resource guide, and that's actually more, gives more details about specific evidence-based, specially designed instructional strategies that you can use with your students. You'll also notice I have a webinar link, and I will be providing this PowerPoint to you. I will drop it into that bit.ly folder after we're done this evening, so you'll have all of these links. But we did do a webinar back in the fall. We actually did 2 webinars back in the fall that highlighted the strategies that were described in both of these documents. So if you weren't able to participate in those webinars, I would definitely encourage you, when you have a chance, to take a look at that webinar, because it really kind of gives us a good summary of what you can find in those documents. As far as resources for today, there is a bit.ly site, and it's going to be on the next couple of slides that you can go ahead and go to. And I'll be referring to some of the resources that are in that folder as we progress. Let me put the link to the site one more time in the chat. Actually, you know what? I just realized what I was doing. I was just doing it to panelists. Here we go. Now you should see it. And that's actually, I'm kind of glad I made that mistake, because when you are posting anything in the chat. If you want everybody to see it, you have to make sure you click on to all panelists and attendees. And that's the mistake that I made. So let me put it in there one more time. That link will take you to that learning disabilities and mathematics page. Okay, so most of you kind of alluded to what the goal of the session is. You all really want to learn about schema-based instruction and how you can use it effectively when you're teaching problem-solving strategies to your students. So hopefully by the end of this webinar, you will know much more about schema-based instruction. So I'm kind of curious to see who is on this call today. So I'm going to go ahead and administer a poll. Whoops. And I'd want you to just let me know what your role is. So let me see here. Let me administer the poll. I'm going to go ahead and launch it now, so you should see it. But out of the 249 people that are here so far, I'm curious to see what your roles are. So take a second or two to go ahead and complete that poll. And we're getting up there in the 200s, a few more seconds. Almost at that 250 mark. I'm going to stop it in about 10 seconds. All right, so I'm going to share the results so you can see who is on the call today. So it's a nice mixture. We have the majority, 43% of special education teachers, which is awesome. You're going to find this really, really, really great to be able to use with your students, as well as the general education teachers that are here. These strategies are evidence-based for students with disabilities, but they're also evidence-based for students with math difficulties who aren't necessarily diagnosed as a student with a disability. I'm also happy to see that we have some administrators and some math specialists, some supervisors. So even though you may not be working directly with students, you can share this information with your colleagues and your teachers at your school and share with them what you've learned. And I forgot to mention, we are recording this webinar. So tomorrow I'll send everybody a link to the recording so you can share that with your colleagues as well. All right, I'm going to stop sharing this. I have so many windows open on my screen here. Okay. So again, that bit.ly site has the resources, some resources that we're going to discuss today, and then you'll have them for when you need them later on. So I mentioned the resource guide. So several of you were able to participate in the webinar that highlighted all the strategies in the resource guide. But today we're particularly focusing on problem solving and most particularly focusing on schema-based instruction. So when you go to that learning disabilities page, which I'll put in the chat one more time in case you didn't get it, that resource guide, if you click on the resource guide, and you can view it right there, or you can download it as a PDF. And this information can be found on pages 28 through 39. And then there's also information in the appendices, F, G, and H. All right, so we're going to look at a typical word problem. This is actually taken from one of our just-in-time quick checks. It's actually from sixth grade, 6.5C is the particular SOL. So just take a look at this problem. The Harmon family is going to an amusement park. The table below shows the cost of the tickets. And they have 3 adults, 4 children, and 2 infants going to the amusement park. What is the total cost? This is a typical problem that 6th graders will see. So thinking about that, we really want to consider that problem solving provides an opportunity for students to demonstrate their mathematics competencies, but oftentimes it's challenging for students with disabilities and learning difficulties. So when you're thinking about what it really means to be a mathematics problem solver, for those of you who are familiar with our curriculum framework, it's defined as becoming a mathematical problem solver represents one of the 5 math process goals. To become a math problem solver, students must apply math concepts and skills and understand the relationship among them to solve problems of varying complexities. They must also recognize and create problems from real-world data and situations within and outside mathematics and apply appropriate strategies to determine acceptable solutions. So in order to accomplish this huge goal, the students really need to develop a set of skills and strategies for all different kinds of problems. So thinking about this, looking at this word problem and what I've just talked about as far as what it means to be a mathematics problem solver, I want you to think about this question. Why might problem solving be challenging for students with disabilities or difficulties in mathematics? Enter your thoughts in a couple of words in the chat box. Reading comprehension, multi-step problems, reading, overwhelming, comprehension, executive functioning, vocabulary, comprehension. I can't read as fast as these are coming up. Breaking the problems into steps, poor number sense, reading comprehension, memory, decoding, multitasking, processing difficulties, language, the reading, yes. All of these are reasons why it might be difficult for students with disabilities in mathematics. Very good, definitely. So all of these areas that you're listing are really some reasons why these can be difficult. So really, because reading and language and the concepts and the procedures, those are all really prerequisites for being able to understand word problems. And because of that, many students really experience some challenges. So it kind of falls into most of what you guys put in the chat box really fall into these 7 areas. Reading problems, I saw that come up a lot. Understanding vocabulary, identifying relevant information, that's a big one. And then ignoring the information that's not needed. And interpreting charts and graphs, which we had a chart in that example. And figuring out what operation am I supposed to do? What operation do I need to use to solve this? And then actually performing the computation that goes with that operation. So those are all really reasons why, or 7 areas of difficulty in terms of problem solving. So those of you who were able to participate in the original webinars probably remember some of this. I'm going to review the 3 main pieces of advice in terms of word problem solving. But again, we'll spend most of the time on the schema-based instruction. But when you're thinking about word problem solving, there's really 3 considerations. And the first one might come as a surprise to some of you. The first one is don't tie keywords to operations. That's a big one. And I'm just as guilty of it as probably many of you are. I know that when I had a classroom, before I learned and knew better, I had keyword posters hanging up in my classroom. Well, I'm going to share with you why that does not work. Okay, so that's the first thing. And then the second piece of advice is you have to have an attack strategy. Oftentimes students look at problems and they're just like, I have no idea what to do. I don't even know where to start. They need to have a specific attack strategy that they always use when they're attacking word problems. And that can help them. And the more they use it and the more they practice it, the better it is because they will know how to approach the word problems. And then the last one, of course, which is the main topic of the webinar, is you do want to teach word problem schemas. So basically you're replacing those we're not using keywords, but instead of using keywords, we want to teach word problem schemas. So here we are. Some of you probably have posters like this in your classroom right now, where you have them on your virtual, in your virtual classroom, hanging up behind your, with your emojis and stuff. But like I was telling you earlier, the strategy is not effective. Oftentimes, when keywords are tied to operations, the students kind of just look through the problem. They don't really even read it. They just kind of do a seek and find to find the keywords. Like, oh, I see altogether, I'm going to add. And they don't even really think about the problem. They don't think conceptually about what's going on. They just look for those keywords. And then a lot of times those keywords the operation doesn't even work for that particular problem. So if you have any of these posters, or you have kids that have these in their notebooks or whatever, we want you to get rid of them. Okay, and this is for all students. This is actually something that we want to remember for all students. This doesn't work with any student. You don't want to encourage tying keywords to operations. The other thing you don't want to do is you don't want to give a kid a worksheet that says division word problems. And then obviously they're not going to really read the problems. They're just going to look at them, take the numbers and divide them. So that's another thing we want to avoid. And so again, it just doesn't make sense to do this. Why encourage the use of keywords when it's really not effective? And it doesn't encourage conceptual understanding. Here's just an example of a keyword that actually works in one situation and doesn't work in the other situation. Oftentimes students associate the word share with division. Well, you can see in the first example, it would indicate division because she's sharing 36 brownies with 6 friends. But then in the second situation, you can see it's not division. That operation would actually be subtraction. Okay, so not only does it not encourage conceptual understanding, but half the times it doesn't even work. So if you remember those three pieces of advice on the couple slides before. So the first piece of advice was don't tie keywords to operations. The second piece of advice was to teach students to use an attack strategy. And the third piece of advice was schema-based instruction. So those two pieces of advice, the attack strategy and the schema-based instruction, those are actually considered cognitive strategy instruction, CSI. We have lots of acronyms. And cognitive strategy is really teaching kids how to learn rather than mastery of specific content. So the attack strategy is a cognitive strategy instruction as well as schema-based instruction. So the second piece of advice is do have an attack strategy. So here are just a few examples. And I'm not telling you what attack strategy you have to teach your students, but whatever attack strategy you decide to use with your students, you want to make sure that you teach it to them explicitly and that they do it so much and they practice it so much that it just becomes part of what they do. Here's an example of one that I think a lot of people use this particular strategy. It's the UPS check strategy. And these visuals kind of show you what each step of the process is. So you really want to make sure that whatever attack strategy that you use, that it helps students structure their thinking before they solve the problem and during when they solve, or when they solve the problem. So attack strategies are grounded in those metacognitive strategies and oftentimes are associated with a mnemonic or an acronym, just like the UPS check or the RICE or so forth. So they often include self-regulation components where students ask themselves questions and monitor their performance as they solve a problem. So when you're teaching the students the attack strategies, you want to model that self-talk. You want to do those verbal thinking, what am I thinking? Think alouds. You want to verbalize what you're thinking so that the students can then do the same thing when they're doing that attack strategy. So whatever attack strategy you decide to use, you want to make sure that you provide explicit instruction, teaching without modeling and practice, so that the students can learn to apply that strategy whenever they're attacking word problems. So just also keep in mind, it's great to have these strategies hanging in your classroom as a reminder, but where some students who don't display difficulties in mathematics, they might be able to just look at that strategy and use it as they're solving the problem. A lot of our kiddos who have disabilities in mathematics or difficulties in mathematics need that explicit instruction on how to use that attack strategy. All right, so now we get to the meat of the webinar, which is what you're all here for, the schema-based instruction. So with schema-based, so we're basically using this to kind of replace using keywords. It's much more effective and evidence-based to use schemas. And basically it's where students learn how to use cues in the word problems to determine the type of problem. So those of you who are familiar with our curriculum framework, in 3rd and 4th grade, they refer to problem types. And those problem types are really schemas. So I will kind of compare what they're described in the curriculum framework to kind of make that connection for you, but it's the same idea. So students learn concepts to choose the appropriate procedures to solve the problem. So they're looking at the structure of the problem. A lot of times students with learning difficulties have trouble setting up and solving the word problems. They just, like I said, they just don't even know where to start. They don't know how to set it up. They have challenges identifying that relevant information and figuring out the operation. So to alleviate those difficulties, teachers can help students focus on the underlying schema or structure of the word problem, and then provide practice in identifying that relevant information. And then the other key part of this is using graphic organizers, which is an evidence-based strategy. Graphic organizers can be used in so many different contents as well, but it helps the students organize the information visually and to be able to visually see the structure. So we have 6 schemas. We have additive schemas and we have multiplicative schemas. So most routine word problems that students see in elementary and middle school fall into one of these 6 schemas. So we're going to first start talking about the additive schemas. All right, so our first one is called the total schema. So those of you who are familiar with the curriculum framework, which if you teach math, and even if you're a special ed teacher who teaches math, you really should be familiar with the curriculum framework. They're referred to as part, whole, or combined problems in the curriculum framework. But it's basically parts put together into a total. So some of you had mentioned gestures in the beginning, wanting to learn some gestures to help students with solving word problems. So this is a gesture that can go with it. You're putting parts together to make a whole. And it doesn't necessarily mean it's only 2 parts. It's just parts. It can be more than 2 put together to make a whole. So in total problems, the unknown could be the total, but it could also be one of the parts. So I'm not going to read all these examples to you because you can read them yourself, but each of these examples is kind of the same situation with Erin and her birds. But the way the question is asked, the first question is asking for the total, and the second 2 questions are asking for the parts. So a student would recognize this as a total schema and then fill in the parts of the graphic organizer. So here's an example. So again, you can see that I put that, I want to make sure that my students are using those attack strategies. So a lot of times having that visual next to your problem helps students to remember to do those steps. So in understanding this problem, of course, the student would read it. Megan baked 28 sugar cookies and 24 chocolate chip cookies. Enter the total number of cookies Megan baked in all. So in understanding that problem, I know she has 28 sugar ones, 24 chocolate chips. I want to know how many cookies she has in all. So, wow, I think that's a total problem. So then I would go ahead and use my total schema graphic organizer and fill in what I know, and then figure out what's the unknown. So in this case, obviously we know the parts, we know the sugar cookies and the chocolate chip cookies, but we want to know the total number of cookies. That one's probably one of the simplest schemas and might be one that you want to start with. The next schema is the difference. And the different schemas are actually referred to as compare problem types in the curriculum framework. And this is where you're looking at a larger or a greater amount and a lesser amount, and you're comparing them for a difference, which is why they're called compare in the curriculum framework. So the gesture that would go along with this is you have a larger or a greater amount and a lesser amount, and you're finding the difference between those. You can also do it like a number line. And I don't know if this looks, I can't remember if my camera is mirror or not, but if this is the lesser number, and this is the greater number, so you're finding the difference. Here's an example. So if a student was attacking this problem, of course, they'd have that attack strategy right by there to remind them of their steps. They want to try to understand the problem first. So Jana has 107 wooden beads, 68 glass beads. How many more wooden beads than glass beads does Jana have? So I'm comparing how many wooden beads she has to glass beads. So this would indicate to me that I'm thinking about a different schema. So this is what the difference schema graphic organizer looks like. So once the student recognizes that it's a different schema, then they would go ahead and complete the parts of the graphic organizer. So we know that the greater number is 107, and we know that the lesser number is 68, and we want to know the difference between that number. So if you're using your gestures, the greater number is 107, the lesser number is 68. What is the difference? So then once the student has those numbers completed and filled in the graphic organizer, then they can look at that structure conceptually and decide how they want to solve it. Some students might subtract 107 minus 68, but some students might say, you know what? I know that 68 plus 40 is 108. And if I just take one away, that's 39. So that student's actually adding up. So this is another reason you don't really want to tie keywords to operations, because some students will subtract, but other students might see it as an addition statement. And that's the nice thing about these graphic organizers, is it doesn't indicate the operation. The student looks at it conceptually and what they understand, and they choose what they understand the most in terms of what operation they want to do. I'm trying to keep up with the chat, but I can't multitask that much, but I'll stop in a couple minutes to see if there's any questions. So the last additive schema is called the change schema. And that is where you have an amount. So if you're thinking about your gesture, you have an amount, and that amount is either going to increase or that amount is going to decrease. So you can have change increase or you can have change decrease. In the curriculum framework, the change increase, those are called join problems. And here are some examples of the same situation. It's the same kind of story problem, but the way it's asked is asking for different parts. So as you can see, the first example, is looking at is asking for the end result. She starts with $4. She earns $3. What's her end result? But as you can see, if it's phrased differently, it could ask for the change. It could say she has $7. She started with $4. What did she make? So that would be asking for the change, or it could ask for the start number. So again, there's no operations indicated in this graphic organizer. You just you identify what numbers go where, and then you look at it conceptually and decide what operation you want to do. And then here's an example of a change decrease problem. So in this situation, you're starting with a number and you're decreasing. So that would be the gesture that goes with it. And in the curriculum framework, the change decrease problems are referred to as separate. So in this example, your situation is cookies and she eats 2 of them. So, and as you can see, it depends on how the question's phrased and what it's asking for. The first one is asking for the end result. The second one is asking for how they change, for what the change is. And the third one is asking what the start number is. I also added those equivalent addition statements just to kind of emphasize that even, you know, once the student puts it in the graphic organizer, they might think about it as an addition sentence, and that is okay. We want them to think conceptually and what makes the most sense to them. So here's an example of change with a strategy. So again, keeping in mind that we're using our attack strategy, I'm going to understand the problem first. So the bus has 13 passengers. At the next stop, more passengers got on the bus. Now they're 28. How many passengers got on the bus? So I know at the end there's 28, but it started with 13. And I want to know how many got on the bus. So I think to myself, well, I'm starting with a number and I'm ending with another number. So that's a change schema. So again, you use the graphic organizer and you fill in the numbers you know, and then you look at that structure and schema and decide, well, what operation am I going to use to solve this problem? Again, some kids might add up 13. What do I add to 13 to get to 28? Some kids might subtract. So really, again, there's no, you know, it really, really depends on what their conceptual understanding is and what makes the most sense to them. But either way, they should still get that change of 15 passengers. So I showed you the schema gestures, but this link will actually take you to a video that has the gestures. This is Sarah Powell, and she was actually one of the co-authors of our two documents that we have on our website. She's done a lot of work with schema-based instruction, and actually this STAIR, supporting teachers, teaching of algebra individual readiness, they have like, gosh, I don't even know, they have a bunch of videos on different evidence-based ways to teach different math concepts. So anyway, this video will show you those gestures again. All right, I think I'm going to take a breath. I haven't been able to keep up with the chat while I've been talking or the question and answer. So I'm going to ask Teresa if there's been anything that's come up in the chat or question and answer that I should address to the whole group.
One of the questions, will they get the PowerPoint?
Yes. So in the bit.ly, they all have the bit.ly link that has the documents. I'm going to drop that into there after we're done tonight.
Another question, some folk want you to show them the difference hand motions again.
Okay. So for the total one, you have parts combined to a total. Parts combined to a total. For the difference one, you have a greater amount, a lesser amount, and you want to know what the difference is. And then for the change, you're actually, I don't know if I showed you this one. I may not have showed you this one. For the change one, you're starting at a number and it's either increasing or you're starting at a number and it's decreasing. You could also do it like a number line. You're starting in a number, and I don't know if I'm going the right direction because I can't remember if I mirrored or not. And you're increasing. I think that's the wrong way. I don't know. Or decreasing. But you guys understand. But again, those gestures are in that video as well. Any other questions?
There's one more on the multi-step problems, and obviously you're going to get to that later.
Yes, I knew that they would want to know some information about multi-step problems, so stay tuned.
And that's good.
Okay. All right. So now we're going to practice a few. So I'm going to show you a word problem. And actually you can see it right now, can't you? I want you, so some of you, I didn't realize I had already gone to the next screen. So some of you have already been looking at this. So you might've been able to think about it a little bit while I've been talking. But I want you to read this word problem and I want you to decide which schema you think goes with the word problem. Sebastian scored 12 goals. James scored 19 goals. How many fewer games did Sebastian score? Okay, I see a lot of people putting difference. I see somebody put change, difference. All right, great. So it looks like the majority of you chose difference. And I did notice that some of you chose total. There's a couple that chose total and a couple that chose change. And I do want to say there's not always one right schema. It really depends on how you look at the problem. So in this case, for the most part, people will see it as a difference problem, but some people might see it as a total problem or a change problem. And as long as you can justify your thinking, right? We want kids to just justify and explain their thinking and it makes sense. That's okay. You know, that it's okay. So I looked at it as a difference problem. You know, 19 is the greater number, 12 is a lesser number. What we're trying to find the difference. And again, kids might subtract to get this answer. Some kids might add up to get the answer. And either way is fine. So we're not tying it to one operation. All right, so here's another one. And this time I want you to not only tell me the schema, but why you think that is. So it might take us a little bit of more time on this one, but I want you to kind of justify your thinking on this one. So tell me which schema and then why you think it's that schema. So she has $32 and then she earned some money for cleaning her room and now she has $47. So now we want to know how much did she actually earn for cleaning her room. So tell me what you think it is and why. So a lot of people are indicating change because we have the start and we have the end. I see somebody indicated total. If you indicated total, tell me why you chose total.
Kristen, there's a couple questions in the question and answer that you might want to try to explain in relationship to integers in algebra.
Okay. All right, so it looks like we had some people who saw it as a change, and then I think some people saw it as a total. And you explained why, you justified your thinking, and guess what? That's awesome, because they both work. So you could look at it as a change problem. You're starting with the $32, you're ending with a 47. What's that change amount? But you know what? I noticed that some other people also saw it as a total problem. There's a total amount of money that she has now, right? She had $32, which is part of her money. What's the other part? That other part is how much she made cleaning her room, right? Either one of those is going to work. And that's totally fine. That's the cool thing about these is that we want kids to use the structure that makes the most sense to them. And they both work and they both make sense. And you're gonna get the same answer regardless of which one you use. Okay, let me do one more of the additive schemas and then I'll address the questions and answers from the Q&A. All right, here's another one. In this one, you just have to tell me which schema. Which schema do you think? She has 25 red and purple markers. If 12 of the markers are red, how many are purple? I see most people are putting total. I see a difference or change. Okay, and again, if you see it as something else besides the total, if you can explain and justify your thinking and it makes sense, and you end up getting with the same result, that's perfectly fine. Most people saw it as a total. And Michael just said he sees a way to use all of them, and that's okay, Michael. And you want your and your students, but your students may not see which way you can use all of them. You want them to pick the schema that makes the most sense to them. So yes, you're right that you could use other ones. This is probably the most common one that students would choose. But again, if they see it in a different way and it makes sense, that's okay. All right, so before I move on to the multiplicative schemas, Teresa, you said there were some questions in the Q&A. Do you think the different schema might create some misconceptions when students begin using integers in 6th grade? Stephanie, yeah, I think that integers will kind of add an extra challenge, but they'll still, when they're using the schemas and they're looking at that schema and deciding whether they need to add or subtract, they're still going to have to perform those operations. And in which case, when you're actually doing the operation, you might pair it with a number line, you might pair it with some integer chips. So they would use the schema to figure out the structure of the problem and decide what operation they want to use to solve it. But then you might pair it with that concrete and representational representations to help them figure out that final answer. Is there a resource for pre-written word problems in these different forms and schema types? In the bit.ly folder, I did share some examples of word problems. And then in some of the other resources that are shared there was a research article in the bit.ly, has some examples. And then there are also some links to some examples in the actual resource guide itself. Linear system word problems. Miss Duchy asked about that, and that's kind of beyond my content expertise with linear systems. I would have to think about that one and get back to you on that one. But that's a really good question because you're thinking about that the high school concepts.
Kristen, I think some of the resources that you shared with her from Sarah Powell will probably help with that also.
Yes, definitely. Yeah, and those are all linked in the actual resource guide. And I'm also going to share some additional resources at the end of the PowerPoint that will take you to even more resources. All right, so we've talked about the additive ones. Let's go to the multiplicative schemas. So the first multiplicative schema is considered equal groups. So you're thinking about you're having groups that are you're multiplying the groups by a certain number in each group for a product. So when you're thinking about the gesture, you have groups and each group has an equal number in that group. So that's the gesture that goes with it. So again, just like the other additive problems, when you're looking at this graphic organizer, so you have the group, you have the number or rate, and then your product. And depending on what the question's asking will determine what part of the problem you're looking for. So in our first example, she has 2 bags of apples. That's the group. There are 6 apples in each bag. That's the number in each group. How many apples does she have all together? So in that case, they're asking for the product. In this next example, so it gives you the product. She has 12 apples, but she wants to share them equally among her 2 friends. So you're thinking about, well, how many apples does each friend get? So in this case, we're thinking about what that number is. And again, you know, if you're using those keyword strategies, kids are going to say, oh, share means to divide. But some kids may not divide to solve this. They might know, well, 2 times 6 equals 12, right? And then that last example with the same situation is she's telling you that each group has 6 apples. How many groups are there? So here's an example with a strategy. I'm going to probably have to try to talk a little bit faster so we can get through all this. But again, encouraging that you use that attack strategy. So he has 6 cartons, that's our group, and each carton has 25 cherries. So we're looking for the product. Our next multiplicative schema is considered comparison. And these are typically introduced after equal groups. And it's when comparison problems, you're looking at a set that's multiplied a number of times for a product. So the schema that goes with this one is you kind of have to think of it like a number, like an imaginary number line. And you have a set and you're multiplying it a certain number of times, kind of like hops or jumps. You have a set, multiplying it a certain number of times. And again, just like all of our other examples, sometimes the question's asking for what the product would be. Sometimes it's asking for the set, and sometimes it's asking for what that multiplier is. So in this situation, the first example, Sam has 6 apples, Elizabeth picked 2 times as many. So we're looking at how many apples does she have? That's the product that we're looking for. In the second situation, we're giving the product that she picked 12 apples. She picked 2 times as many. So that's the multiplier. And we want to know what the set is. Sam would be the set. So again, once the student fills in the graphic organizer, then that student can look at the structure conceptually and decide what operation. Some students might choose to multiply depending on what they're finding. Some students might choose to divide. Some people might do repeated addition or repeated subtracting if that's how they think about multiplication and division. Here's a quick example of comparison. Susan has 3 times as many books as Mary. Mary has 18 books. Which equation can be solved to figure out how many books Susan has? So we're figuring out how many books she has. So Mary has 18 and Susan has 3 times as many. So this would be considered a comparison schema. Mary has the 18. Susan has 3 times as many. So how many does Susan have? So we're looking for the product in this situation. All right, the last multiplicative schema is the ratio and proportion schema. And those of you who are familiar with the math curriculum, you're not going to really do too much with ratios and proportions until you get to middle school in 6th and 7th grade. So this schema is very commonly used when you get to middle school. And it's most commonly used with ratios and proportions. So here are just a couple of examples. So in a ratio and proportion problem, you're thinking about a relationship among quantities. So when you're doing ratio problems, proportion, percentages, unit rate, all those types of problems would fit into the schema. And here are 2 examples. Bricklayer laid 92 bricks in 2 hours. At this rate, how many could he lay in 10 hours? So the schema that goes with this one is this is to that as this is to that. This is to that as this is to that. So if you're thinking about this, 92 bricks is to 2 hours as how many bricks is to 10 hours. Here's an example with a unit rate. 1 box of crayons costs $2.49. How much do 7 boxes cost? So if I'm thinking about this, if 1 box costs $2.49, then 7 boxes cost how much? Here's an example using the strategy. I'm going to use my UPS strategy. I'm going to understand my problem first. There are 176 slices of bread and 8 loaves. If they're the same number of slices in each loaf, how many slices of bread are in 5 loaves? So I'm comparing a relationship between these quantities of slices of bread. So that means I'm going to be using my ratio proportion schematic diagram. And I fill in that if this is to that, this is to that. So if there's 176 slices of bread in 8 loaves, then how many slices of bread are in 5 loaves? And again, in terms of solving it, once you have it in that graphic organizer, students can solve it that makes the most sense to them. You know, some students might think to themselves, well, 8 times what is 176? Or they might do 176 divided by 8. And then, so if they do 8 times what equals 176, then they would multiply the 5 times that same number. So how they actually solve it and what operation they would, and some kids would use, cross multiplying and divide, which that's probably not, I would probably actually not encourage that as much because it's not as conceptual. So I showed you these schemas as I was explaining them, but again, this video it has all of the schema gestures for all 6 schemas. All right, so I see a lot of stuff in the chat. I haven't been able to, yeah, I agree with that. The cross multiplication, yeah, we don't want to do cross multiplication because it does, or yes, I don't want to do the butterfly either. That's not, yeah, we don't want to do the cross multiplying. I always told my kids if they ever heard about the butterfly method that the butterfly has flown away, that we don't use that anymore. We definitely wanted to promote that conceptual understanding. Teresa, were there any questions that I should address, or can I do a couple examples and have them guess first?
There was one question about, is it problematic to say total instead of product when using equal group schema?
No. And that's actually another reason we don't want to do keywords, because you have to understand the structure of the problem. So yeah, I mean, and when you're asking for the product, a lot of times it is a total. So that's again why we don't want to always associate with total with adding, because it could indicate a different operation. All right, so let's see here. Let's see how you're doing. I need you to think a little bit here. I know this is a lot. This is a lot in an hour and a half. I'm kind of giving you the broad overview, but hopefully you'll be able to digest it and use some of it in your instruction. So this one, I want you to enter what you think and why. So we're going to justify our thinking in this situation. Charlotte has 4 times as many stickers as Kyra. If Charlotte has 24 stickers, how many stickers does Kyra have? So you're trying to decide if it's equal groups, comparison, or ratio and proportions, and try to tell me why too, if you can type that quickly. So comparison, comparing 2 parts. There's a multiplier. 2 people are involved, comparison, because it looks like most people are seeing that as a comparison. So we're really comparing the number of stickers that Charlotte has to Kyra, which is why a lot of us see it as a comparison problem. But again, if you saw it as something different and you can justify your reasoning and it makes sense, that's okay. So in this case, we know that the 24 is what Charlotte has, but she has 4 times as many as Kyra. So if she has 4 times as many as Kyra, we know that Kyra has less. She has a smaller number of stickers. And yeah, I would agree with John. I don't think this necessarily goes with the ratio proportion. I could probably see how some people might think of it as an equal groups, but I think it would be difficult to put into the ratio proportion. All right, how about this one? A classroom has 6 rows of chairs with an equal number of chairs in each row. If there are 30 chairs in the classroom, how many chairs are in each row? Is it a equal group, comparison, or ratio and proportion? Most people are putting equal groups. I saw somebody mention unit rate, and I can actually see how you would look at it as a unit rate, and you could potentially put it into the ratio proportion schema. Okay, so it looks like most people chose equal groups, and that's the one I put up here. But again, if you saw something different and it's justifiable, I think the ratio one, you can think of it like a row would be your unit, right? So if there's 30 chairs and 6 rows, how many chairs are in one row? That would be the unit rate. All right, one more. Marianne ran 12 laps in 3 minutes. How many minutes would it take Marianne to run 60 laps?
Kristen, they would like for you to put the bit.ly link in the chat again.
Okay. I will do that right now. All right, here is the bit.ly link. All right, so I was typing, but I think most people were putting ratio proportion in the chat. And yes, that's how I saw it. She runs 12 laps in 3 minutes, then she runs 60 laps in how many minutes? And again, when you're looking at this, kids will solve it different ways. Some kids might say, oh, 3 times 4 is 12, so what times 4 is 60? Some kids might see the multiplicative relationship this way: 12 times what is 60, so 3 times what equals 15. Some kids might divide: 12 divided by 4 is 3, 60 divided by 4 is. All right, so getting to the multi-step. I know that's a big question a lot of you have. How can we apply this to multi-step problems? Because multi-step problems can particularly be difficult sometimes for students with math disabilities and difficulties. So yes, you can apply these to multi-step strategies. So ideally, in a perfect world, our students would be exposed to these schemas when they start school in kindergarten, first grade, second grade, and be really familiar with them, with those one-step problems. And then it would be a nice transition and in being able to use them for 2-step problems or 3-step problems. I know that it's different for those of you who are teaching middle school and high school and upper elementary. You know, some of your students probably have never been exposed to schemas. In fact, a lot of them probably haven't been exposed to schemas. So you do have a little bit more of a challenge because you need to kind of go with the one step first to introduce them to the schemas before you can get to the multi-step. So I do acknowledge that it is challenging to start schema-based instruction when kids are older, because you're going to have to start with those one steps so they can understand the schemas, but it probably won't take them as long to learn them, you know, because they're older and they have more experience with math. But as far as when you're thinking about multi-step strategies, you're really just taking all the individual schemas and you're combining them for depending on what the multi-steps involve. So sometimes a student can tell you, well, I need to do this first, and that goes with this schema, and I need to do this second, and that goes with that schema. And if they can do that, that's great, because then they, you know, they can take those individual schema diagrams and complete the first one and then complete the second one. Sometimes it's hard though for students to figure out what do I need to do first? I have no idea. So in that situation, a strategy that they could try to use is working backwards. So you're kind of figuring out, what do you not know? Like, what are you trying to find out, and work backwards from there. And then as you work backwards, you can develop your plan. So those are a couple of different strategies you could try. But again, the biggest thing I would recommend is if students have not had experience with schemas, you're gonna have to start with the single step problems first for them to even be familiar with the individual schemas. So here's an example of a multi-step problem. And this is actually taken from another just-in-time quick check. I think this is from the 6th grade. But so here's the situation. Connor's saving to buy a new bicycle for $140.20. He's already saved $25.50. If he saves an additional $15.50 each week, how many weeks will it take for Connor to have enough money to buy the bicycle? So if I'm looking at this one, some students might realize, you know what, before I can even figure out how many weeks. So the unknown is I want to find out how many weeks I need to save till I can buy my bike, right? Well, they realize they need to figure out how many weeks. Well, they first have to figure out, well, how much money do they still need to save? So kids might realize, you know what, before I can figure out how many weeks, I need to figure out how much money I still need to save. And I started with $140.20. I've already saved $25.50. So what's the difference? What's left over? So those kids would realize that, well, first I need to do a difference schema to figure out what's left over that I still need to save to buy the bike. And then once they find that difference, that's actually, then they're thinking about, well, now I need to think about how many weeks do I have to save it? So that's actually, so I have a certain amount of money, the $15.50. I'm saving that each week. So that indicates each week is kind of like a group. How many groups or how many weeks do I need to save that $15.50? So again, we're starting with 140. We're going to do the different schema first. We have the greater number of $140.20 minus that $25.50 that I've already saved, or less that $25.50. What's the difference? Some kids will subtract to find the difference. Some kids might add up from $25.50 to $140.20, but regardless, they would get the $114.70. So that's what I end up. That's what the product is in my equal groups problem, because that's how much how much more I need to save. So that number then would go down into the product. And our number in each group, the amount of money in each week is $15.50. So we're figuring out how many weeks or how many groups. So that would be an example of being able to kind of figure out what would I do first. I would do the different schema. And then second, I would do the equal group schema. Here's another example. Over the summer, Audrey had a job and earned $528. She spent $125.70 on a new bike and $85.09 for some new clothes. How much money does Audrey have left? So some kids might be able to look at this and tell us, well, first I need to figure out how much I spent on clothes, and that's the total problem. And then I need to figure out the difference of the total amount of money I started with or earned minus what I spent on clothes on a bike. So some kids might be able to figure out what I do first, what I do second. Somebody said they just used this in class today. That's awesome. So, but just to kind of give you an example of how you might work backwards. Now, this might not be a typical way that students think about it, but I just wanted to kind of give you an example of how you can work backwards. So I want to think about, ultimately, I want to know the difference between the money I had and what I spent and how much I have left. So that's kind of my unknown. I want to know that difference. I know that the greater amount, like what I have to start with, is the $528. And from the less amount is what I spent on my bike and my clothes. I don't know what that is yet. I know what I spent on them individually, but I don't know what I spent on them together. Well, that green arrow, so we can't solve this yet because we have two question marks, right? Well, that green arrow is actually, that less amount is actually the total in step one. So the total of the $125.70 on the bike and the $85.09 on the clothes, that green question mark, the total, would then be the less amount in our difference. Okay. And just like with the one-step schemas, you might look at this totally different than I looked at it. You might identify a different schema to use, and that's okay. Remember, as long as it makes sense and you're conceptually understanding what you have to do, you might see it totally different than I just saw it. So in that bit.ly folder, I did include, I included some templates. So I have templates for the 6 schemas, and I made sure they were big enough. They were 8.5 by 11. So if you're in a face-to-face classroom, you could print them out. And a great way to reuse them is using those nifty plastic sleeves where kids can use expo markers and write in their answers and erase and so forth. And then I also put in several multi-step templates that also fit on the 8.5 by 11. If you're not in a face-to-face classroom, I can see you using them on Google Slides or Google Jamboard, using the Google Jamboard with sticky notes and putting the numbers in and so forth. So you can use them however you need to in your setting. I put several combinations together for the multi-step. They're not all the possible combinations. So another strategy you could use is when you're doing the multi-step problems, still using the one-step graphic organizers, but manipulating them and moving them around. And that actually would be helpful when students are trying to figure out what they need to do. All right, so this is a lot of information in an hour and a half, and I totally acknowledge that. This is the kind of thing where you really just need to take some time to digest. This is something different than probably any of us learned when we were in school. And it's totally different from the keyword strategy, which we don't want to use anymore. So it does take some time to digest, and it can be very overwhelming. It took me a long time to digest it and really understand it. So if you're feeling a little overwhelmed right now, I'm like, oh my gosh, this is so much. That's okay. You're getting a lot of information in an hour and a half, but hopefully I've provided enough guidance and enough resources and support to help you get started. And I'm going to give you some tips as far as when you're working with students with disabilities or difficulties in mathematics. So one thing you really want to think about is that you don't want to think about how you felt when I threw all 6 of these schemas at your face in an hour. Totally overwhelming, right? So you want to do one schema at a time. And you don't introduce another schema until that student is starting to understand and gain proficiency with the first schema that you introduced. And the other really important thing is you want to make sure you use problems that are easy for them to understand. So they might be at a lower grade level. They might be, at a level where they're actually performing above that level. But in order to really understand the structure, the problems I gave you guys were pretty simple problems, right? And the point of that is to help understand the structure of the schema. So when you're teaching these schemas, use simple problems. And once they understand the schema and the structure and how to use them, that's when you can transition to the problems that are more appropriate for their grade level, or where they're functioning, or what their IEP goal is. If their IEP goal is on word problem solving, that's where you can start working on what's focused on the IEP goal. And the other thing to think about is that, oftentimes students with disabilities will need that more intense and systematic instruction than others. So these schemas could work in the general classroom too, right? With all students, these are great. But the thing you need to remember is that oftentimes students with disabilities need much more explicit instruction and a lot more practice opportunities. And that's where that specially designed instruction piece comes, that special education piece. If you're a special educator and you're working with a general education teacher in a co-taught class, this is where you can really hone in on that specially designed instruction. And you might teach schemas to the whole class, but some of your students who have disabilities in mathematics or have IEP goals in math, they're going to need that more explicit instruction and practice. And kind of like how I alluded to before, you want to include, you really just want to do one at a time. You're gradually increasing, you're gradually introducing new schemas as they gain proficiency. So you'll start with one, they get pretty comfortable with that one, introduce a second one, and don't move on to the third one until they're pretty good at discriminating between those first two. Okay, you need to do it very intentionally. You don't want to do all 6 at once like I just did with you. So if you had a chance to take a look at the bit.ly resource, Amy brought up a good point. Curriculum framework does tell where to introduce each problem type, and you're right about that, Amy. That's a good point. So go ahead and, if you haven't gone to the bit.ly site yet, go ahead and go to it now. The link is up here on the screen. And you'll notice that there are the templates that I mentioned. So there's templates for each of the 6 schemas, and then there's several multi-step templates. So again, use them that fits your instructional setting. There are several example problems for additive and multiplicative schemas. I also put in some examples of the UPS check strategy for the attack strategy. That seems to be a very common one. I think kids are pretty successful using that strategy. So there are a couple of documents that are posters that you could hang in your classroom or have them put in their notebook. And then there's also, there's one that actually shows a couple of different examples and like with very detailed descriptions of what you would do for each step for that particular problem. And then there's some research articles on schema-based instruction. So before I go to the next slide, we covered multiplicative schemas and multi-step problems. Teresa, are there any questions from the Q&A that I should address before I go to the next slide?
I know there was a statement, and I think you cleared that up about could there be more than just 2 parts to a problem?
Oh yeah, yeah. There could be 3. There could be 4. I think there's actually one template in there that it's a 3-step one. But again, I didn't come up with all. I don't have all the possible combinations for the multi-step, but that's where I think you can just take the individual 1-step graphic organizers and have the students manipulate them. Well, this one I want to use for the first step. This one I want to use for the second step. All right, so let's take a look at this question and see if we can share some ideas with each other. I know everybody is in different situations now. Some of you are face-to-face, some of you are 100% virtual, some of you are doing the hybrid, some of you are doing concurrently where you're teaching face-to-face and virtually, which my hat's off to you. I never had to do that, and I can imagine how hard it is. But I want you to think about your situation. And we just kind of took a look at some of the resources that are in the bit.ly site. Enter into the chat any ideas that you have that could be helpful in implementing schema-based instruction. So I shared a few ideas with how you could use the templates and so forth, and I gave you some instructional tips. But you're all educators, so let's share ideas with each other. Do you have any other good ideas of how you could implement schema-based instruction? And if you do, please put them in the chat. Jamboard idea with the stickies. Yeah, I think that's going to be, if I was doing virtual, I definitely would do Jamboard with the stickies, because you could put the schemas on the large part of the Jamboard, and then the students can use stickies to move for their numbers. Display anchor charts. Yes, actually, that's a really good, I'm glad you brought that up about base 10 blocks. This can be paired with that concrete representational abstract strategy that was also shared in these guides. You know, we don't just have to use symbolic representations. We can use manipulatives and put the number with the manipulatives into those pieces of the diagram. That is a great, I'm really glad you brought that up. That's definitely the bar model approach would help as well to create those visual models. Creating boom cards. I'm not sure what boom cards are. Ricardo had a question about fractions, and you know what, Ricardo, you can use these schemas with fractions as well. They don't just work with whole numbers. And sharing the templates with parents, definitely. Schema bases up in Desmo Classroom. Oh yeah, you could make some Desmos activities using the schema templates. And if any of you do this, please share them with me. I would love to be able to see them and share them with other people.
Kristen, they would like for you to post the bit.ly link again.
Yes, I just saw that. I'm typing it in again. Color coding. Yes, I love the color coding idea. And that's what I tried to share that with my multi-step problems with the green and yellow. But yeah, I always found color coding helped a lot when I was working with students. All right, so you guys had some great ideas. And like I said, if you do any of these things that you're talking about, like creating Desmo activities or jam boards, I would love for you to send me an email and share them with me. That's one of the nice things is we want to be able to share our resources with each other, right? Brian had a good point. If a child can do schemas with numberless word problems, then they can do the ones with numbers much easier because they're trying to do the sense making rather than matching. That's a good point. Can you add resources to the bit.ly folder? I'm not sure if that would work with the settings that I have on it. If you shoot me an email with it, I can add them to the bit.ly folder. How's that? Let me put my email address in here. So yes, if you create any great resources or find any great resources, feel free to email them to me and I can add them to the bit.ly site. All right, you guys have some great ideas. Awesome. So some of you were asking for some more resources. So here, and again, I will put this, as soon as we're done with this webinar, I'm going to bring over the PowerPoint to the bit.ly site so you'll have it and have access to all these links. But here are some really good additional resources. So, you know, you learned a lot in an hour and a half, and it's a lot to process, and I totally recognize that. So you kind of just have to take it in and process everything. And but if you want to dive into it some more and really process it, here are some great resources you can check out. The word problems, no problem, professional development for educators. Those were actually sessions recorded by William and Mary's TTAC, and they were provided by Stephanie Morano, who's at UVA, and then Sarah Powell, who I mentioned was one of the co-authors of our documents. I think there's 4 or 5 different recorded sessions. And Dr. Morano, I think, focuses on the elementary, and then Dr. Powell, actually, there was actually one recorded session that's solely on multi-step problems. So you could check those out. The National Center on Intensive Intervention at American Institutes for Research, they have some modules on, and this that includes schema-based instruction, but it also includes some other evidence-based strategies for fluency and problem solving and motivation. And then the Center also has some really good information on schema-based instruction. They have several modules for different evidence-based practices. Schema-based instruction is one of those. one of those. I did want to encourage you to sign up for our special education instructional services newsletter. And again, this link is in the PowerPoint, so you can sign up once you have access to the PowerPoint. But these are emails that are sent every couple weeks with resources, upcoming events. For example, this webinar was advertised on this newsletter. So if you want to kind of keep up to date with what's going on with special ed instructional services, I would encourage you to sign up for this newsletter. And then I also included our wonderful resources we have. I think a lot of times people don't realize how many resources we have on the VDOE website, but we have tons of math resources. So use them, right? It makes your life easier. We have mathematics instructional plans from K to Algebra 2 and almost every single standard. We have our co-teaching math instructional plans, which are awesome because they describe what co-teaching models used and what each teacher is doing in the situation. They also suggest specially designed instructional strategies, what kind of accommodations could be provided to students. The mathematics vertical articulation tool, the MVAT, that's really helpful in identifying those gaps in prerequisite skills. And especially now with COVID and learning loss, which, those would be really helpful in identifying some of those prerequisite skills that you might need to do that specially designed instruction in. We have our remediation plans for algebra readiness that go from grades 4 through 8. We have our formative assessments that go all the way from grades 3 to algebra 1. Of course, we have our rich mathematical tasks, our word wall cards, the just-in-time mathematics quick check. Some of you mentioned that you were using those and recognized one of the problems that I had. We have those for every single course from K to Algebra 2, and they help you identify that unfinished learning and help plan your instruction for filling in those gaps. And then I also included the link for those special ed teachers who are in charge of creating goals and for their individual education plans, the skills worksheets that help you write those standards-based IEP goals in math. All right, I'm actually not running late, which is good. I know I kind of rushed a little bit because I was worried I'd run out of time, but you learned a lot in the last hour and 23 minutes. But I want you to think about, for the closure, what's the first step you'll take to integrate schema-based instruction into your problem-solving instruction? And so thinking about what, there's a lot of information. It's a lot to process. So just thinking about it step by step, like we do with a lot of things in our life, what's the first step you can take to integrate this? It might be, I need to rewatch this webinar and really learn each of the individual strategies. So just what's that first step that you're going to take so that you can integrate this schema-based instruction into your instruction? Talking to co-teachers, yes, definitely. Spend time processing and choose a starting point. Share with a math coach, sharing with your special education teachers, create an anchor chart to help you with it. That's awesome. Using the templates and face-to-face, recording your lessons using the schemas. Awesome. Get rid of keywords. Yay. I think everybody should put that as a first step. If you have any keyword posters, take them off, take them down. Using it to create some resources. And again, if you create any really great resources or find any really great resources, please email them to me. I would love to add them to the Bitly site. Introducing it as another way in high school. Practicing, yeah, I think because it is so much to process, we need to practice it ourselves first. It took me some time to get comfortable with schemas because it's totally different than what we learned growing up and what we probably started doing when we started teaching. Start small, yes. Sharing with the general and special ed teachers at your school. That's awesome. All right, so I'm really excited. It seems like a lot of you will take that first step into integrating this into your instruction. I appreciate all of you spending almost an hour and a half with me after you've worked all day. It shows how dedicated you are as educators. So I am going to put in the chat box a certificate of attendance that you can download. Actually, you know what? It's not letting me do that. I thought I could do it in the webinar, but I just realized I can only do that when it's a meeting. So you know what I will do is I will email you the certificate of attendance. I will be able to get the attendance report from this Zoom webinar, and I will email all of you a certificate of attendance.
Or can you put it in the bit.ly?
Yeah, I could possibly do that. All right, well, I appreciate you all hanging in there with me. I'm happy to stay on a few extra minutes if I can answer any other questions. If not, I hope you enjoy the rest of your evening, and I hope that you got something out of the hour and a half that you spent with me.
Will the Zoom video be put in the bit.ly folder?
I can put it in. I'm not sure if it will. I actually will probably just email them the link to the video because it's a web-based.
Okay.
I'll send a follow-up email tomorrow with a certificate of attendance and then also the link to the recording. Which reminds me, I should probably stop the recording right now.